In the world of pro audio, we hear the word transformers a lot. Some products, like microphones and preamps, tout their use of transformers, while others proudly proclaim they use a transformerless design. So what are transformers? They look like this, or this, or this. Sometimes they're in cases, or wrapped in tape. Transformers do a lot of different jobs. They step levels up or down, like increasing the output level of a microphone or bringing an instrument down to mic level. They balance inputs and outputs, match impedance, eliminate ground loops, block DC while passing audio, and the list goes on. A transformer is just two long wires wrapped around one magnetic core. Signal passes from one wire to the other, but the wires don't touch. What sorcery is this? It's a funny feature of our universe called electromagnetism, where electric current creates magnetic fields and vice versa. The electrical current running through the first coil of wire, called the primary, creates a magnetic field in the core. This magnetic field then induces a corresponding voltage in the second or secondary coil. Voila! We now have the same signal at both sides of the transformer without a single electron making the journey directly from one wire to the other. So, if we have the same signal at both sides, how does a transformer step voltage up or down? We only get that exact same signal on both sides when both coils have the exact same number of turns around the core. By changing the number of turns in each coil, we can directly change how much signal is transferred between them. For example, if the primary coil has 200 turns and the secondary has 100 turns, we call this a turns ratio of 2:1, only half the signal will be transferred. This is called a step-down transformer. However, we could turn that same transformer around and use it as a step-up transformer to double the signal. Of course, we don't just keep transformers around to do technical jobs, they also sound really good. There are a couple of reasons for this, mostly having to do with the unique ways in which they fail to be perfectly clean and linear. Like all analog components, transformers clip when given too much signal. Transformer clipping happens when the core saturates and can't contain any more magnetic flux. This sets a hard limit on the amount of signal the transformer can pass and generates harmonic distortion. What makes transformer saturation so lovely is that the distortion it creates is inversely proportional to frequency, which is a fancy way of saying transformers create more warm, gooey, low-frequency distortion and less harsh, bright, high-frequency distortion. Transformers also exhibit another distortion phenomenon called hysteresis. This is the core's memory, where it stays magnetized for a short period of time after the signal is removed. This memory, which is also common to analog tape, creates warm, low-frequency distortion. This is also why a piece of equipment that aims for a wide, clean frequency range would proudly advertise being transformerless. So how does core composition affect the sound? Different materials have different abilities to contain magnetic flux. This is called permeability. Core materials with higher permeability, like nickel, create higher primary inductance, and therefore better low-end response. However, more permeable core materials will also saturate faster than less permeable ones like steel. Ah, nature, where everything is a trade-off. Whether you're chasing the sound of iron or avoiding them to get the cleanest signal path possible, you now have a deeper understanding of what transformers are and what they do. If you have suggestions for audio-related topics you want to know more about, feel free to let us know. Thanks for watching.